So we're out here at the testing pens at the Bimini Biological Field Station where we tested earlier today. And in this large pen here, they have 4 juvenile lemon sharks and 1 juvenile nurse shark. What we basically did was partitioned off this side of the net into an area maybe about 5 feet by 6 feet. And we placed the sharks in there individually and then later in pairs. And we basically just placed the sharks in there, placed our electrodes into the water in different configurations, and just visually took note of the shark's reaction, whether they jerked their head, swam away when we switched the device on, or if there was no reaction at all. We also took note of that. Basically what our device does is takes advantage of a special organ that sharks have called the ampullae of Lorenzini, which detects electric fields in the water, and sharks use that to hunt because all organisms in the water produce a small electric field. And basically what our device does is overloads that organ by creating a strong electric field, and which is strong enough to scare the shark away. So basically what we do is we have a circuit inside this device which creates 60 volt spikes to 2 electrodes. So we have a potential difference of 60 volts between the two, and they go into the water and create a much less strong electric field, which is still strong enough to overload the shark's sense.
Our device is powered by 4 9-volt batteries. We have our switch here, on off. What the first 9-volt battery does is goes in and creates a 9-volt square wave. We come through and amplify it with these batteries, so we get a 36-volt square wave. And we run that through some filters, and the end result is 72 volts, 36 times 2, peak to peak, from one electrode to the other. And it's a spike. It's run at 6 hertz to time up with the shark's nervous system. And so what that does is it creates a field every 6 seconds. So it's not a static field, but pulsing. So now these batteries power that, go through, and when the sharks come close enough to the 2 electrodes, they should be scared off by this field as the field lines go from one electrode to the other. And depending on the distance that we set the electrodes and different settings of the resistors and capacitors, we get different spikes out, and we can play around and get different effects with the sharks.
It's an electrical circuit, so we had to design waterproofing around it. And basically, due to the uniqueness of our design, we had to build a customizable box in order to do so. And as you can see, we decided on a silicone-based mold. It's this blue stuff right here in the middle. And what you can see is we built slots for the 4 batteries. And here in the center, you can see our circuit. And on the 4 sides, we put 5/16 bolts. And also, in order to waterproof it, we had to equally distribute the pressure across both the top and the bottom. And so, as you can see here, we used 1/8-inch thick sheet steel, and we bent it around it. Got a cool little paint job here. And what we do is we lay it over the top, insert these nuts and these bolts and wing nuts through the 4 holes, and tighten it down, and basically that waterproofs the system.